This video will demonstrate several ways to improve the server-side performance of your Sitefinity website. We'll first look at some of the configuration settings for IIS to help optimize your website performance. Finally, we'll look at the relevant Sitefinity configuration settings, as well as some sample code to help ensure best practices. For this demo, I'm using a customized version of the sitemap module sample from the SDK, which has been modified to include several thousand news items which we'll use to simulate a large content website and demonstrate best practices for processing a large number of items. I've also loaded the site in my local IIS to simulate a live environment. In IIS, there are several important settings that can affect the performance of your site, which are accessible from the advanced settings for the application pool in which your site runs. First, it is important to note that the current Sitefinity system requirements specify that you need access to at least 500 megabytes of memory for the site to run. Under the recycling section of the application pool settings is a private memory limit in kilobytes, which, if exceeded, will cause the application pool and website to recycle. This should be set to a minimum of 500 megabytes or, if possible, set to 0 to disable the maximum limit. Next, we'll look at the idle timeout. This setting defines the amount of time in minutes that your application will run idle before unloading. Now, due to the nature of how .NET websites fire up, as well as the fact that Sitefinity initializes several modules and services, the first request to your website will always have an overhead that impacts the loading time. By extending or disabling this timeout here, you ensure that your site continues running, avoiding this overhead on the first request after a timeout. By keeping the application pool running, the site will always be in an initialized state, ensuring it loads as quickly as possible on every request. This can also be enhanced by configuring a periodic automatic recycle of the application pool. This will ensure that your site is reinitialized periodically, which can be important for regularly executing cleanup tasks as well as any required initialization tasks. This ensures that your site is refreshed and up to date, but remains snappy throughout the life of the application. You can set this as a periodic restart here, with the regular time interval property to recycle the pool after a fixed amount of time passes. However, this can result in the pool recycling at random times throughout the day, depending on what interval you choose. You can instead use the specific times property here to pre-program a timed reset at a specific time of day or even multiple times throughout the day, giving you specific control over when your site is refreshed. Finally, in addition to simply recycling your application pool, you want to make sure that the site itself restarts as well, so that the initialization can automatically take place even before any users visit the site. This ensures that the first request warm-up takes place automatically, and your first visit will be served as fast as any other request. In IIS 7.5, this can be achieved with the Application Initialization module from IIS.NET, and is automatically built into IIS 8. Simply install and enable the extension for your website application pool so that it restarts your website when the pool is recycled. Now keep in mind, all of these settings require that you have access to and permissions to modify these settings from within IIS or your website control panel. If you are running Sitefinity on shared hosting, you may not have access to some or any of these properties. In this case, you're encouraged to contact your hosting provider to see if they provide such configurations as an add-on to your existing hosting package. Now that we've reviewed some of the server-side settings you can optimize, let's look at some of the Sitefinity configuration settings that can help improve the performance of your site. Probably the most useful suggestion for keeping your Sitefinity website optimized is to ensure that you are always running the latest version, which is available from Sitefinity.com. Each release brings new improvements to both performance and features, allowing you better control over optimization of your site. One of the newer features in the current version of Sitefinity is the ability to disable modules that your website does not use. This feature is accessed from the administration menu of Sitefinity under Modules. By disabling unused modules, you can reduce both the memory footprint of and the startup times for Sitefinity, since these modules and related services will not be initialized. In this screenshot taken from before this demo, I have almost every module enabled, and my memory footprint is hovering right around 200 megabytes. Now, after disabling all of the unused modules, including e-commerce and the migration module, my site is running at a leaner 148 megabytes. This is especially useful in shared hosting environments where, as mentioned before, memory may be limited. Next, when deploying your Sitefinity website to a live server, you want to make sure that the site is properly configured. Most importantly, you want to make sure that your site is compiled in release mode and that your web config file is set with debug equal to false. This not only ensures that your site is optimized for production, but also ensures that all client-side libraries and resources served through webresources.axt and other handlers like the Telerik RAD controls are optimized, minified, and cacheable by the client. When debug is enabled, these resources are not cached and instead re-downloaded with every request. Disabling debug is an important step to ensuring your site is production ready. You also want to make sure you are taking advantage of Sitefinity's built-in caching options. Sitefinity supports caching at both the server and client side. These are managed from the Sitefinity administration under Settings, Advanced, then System, and finally Output Cache Settings. The output cache refers to the server-side cache, which caches the entire content of each page for the duration specified by the cache. The client-side cache refers to the expires headers for client resources so that they can be cached for extended periods of time on the browser. These settings should usually be disabled during development, but on a production server can greatly impact and improve performance. You can also edit the caching profiles to change settings for the cache duration, as well as enable sliding expiration so the cache lasts as long as the site is actively being used. Finally, you can override these settings at the page level. If you have a particular page that you want to use different cache settings for, or even disable the cache entirely so that the data can be kept fresh on the page without having to set those settings across the site, simply open the Page Properties under the Actions menu, and under the Advanced Options section, you can set the cache settings for that particular page. Now that we've looked at the various configuration settings that impact performance of your site, let's look at an example of what you can do to ensure top performance of your Sitefinity-related server-side code. Custom code in Sitefinity often involves working with the Sitefinity API to retrieve and manipulate lists of content items in a custom control. I've created a simple demonstration using an ASP.NET user control registered as a Sitefinity widget. This control simply displays a list of news items from the total list of 5,000. There are two related ways to optimize requests to the Sitefinity API. The first is by taking advantage of the deferred execution properties of LINQ. By default, queries to the API return the type iQueryable. This allows you to prepare the full query and pass along the full execution of that query, including any filtering, sorting, and paging to the underlying data source. This means that instead of executing such processing to the list of items in memory, as we are doing here, it is done instead by the database, and the completed query is returned, ready to be processed. As you can imagine, the second form of optimization comes into play when you are working with paging, filtering, and sorting. Because the API calls return iQueryable, you can chain additional filters and paging to your API call. Because of deferred execution, no matter how many methods are chained, only a single optimized call will be passed to the database, ensuring that you only return exactly what you need, drastically reducing the execution time for your custom code. To demonstrate this, here is an example of a poorly defined data binding code snippet for our news repeater. Although we are filtering the list here for published items, we are then returning the complete list of items, sorting them in memory, then taking the first 25 items to display in our news repeater. Let's replace this snippet with a better implementation. Now, all of the filtering and paging is offloaded to the single database call. And when we bind, we are working only with the small subset of items through the iQueryable object that is returned. I've added this widget to a test page to demonstrate its output. And using Just Trace, I track the performance of this page by running the profiler during execution of both code samples. The first sample executed the page load method in just under 1,000 milliseconds. This delay is because, as you can see below, the entire result set is loaded into memory, then processed for sorting before being reduced and bound to the repeater. The resulting memory usage peaked at around 113,000 kilobytes. Compare that to the optimized code sample, which used a lean 39K while completing the page load method in a mere 348 milliseconds. Clearly, anytime you are working with the Sitefinity API, or indeed any large list of data items, especially ones loaded from a database, you want to ensure that you optimize both your queries and the result sets so that you are only working with the data you need. Performance could be further improved by caching this result set locally, or adding the page that contains this control to the output cache as described previously, so that subsequent loads are even faster, ensuring a responsive and efficient experience for your website visitors. This video described different ways to optimize the server-side performance of your Sitefinity website. By taking advantage of IIS and Sitefinity configuration settings, you can optimize both the startup time and memory footprint of your site. Optimizing your Sitefinity API calls with deferred execution, filtering, and paging also ensures that your custom code also performs at peak efficiency. For more information on server-side optimization or any other Sitefinity topic, be sure to visit sitefinity.com/documentation, and thank you for watching this video.